Hi, I'm Joyee. Thanks for joining me. Today I'm going to share a bit about the journey of require ESM in Node. So quick self-introduction. I work at Galia. I've been sponsored by Bloomberg on some of the work I do on Node.js. I am a member of the Node Technical Steering Committee and a VA committer. You can find me on GitHub via the handle Joyee Cheung. So to introduce what we are going to talk about today, raise your hand if you have seen this error. Oh, yeah, a lot of people. So these are now gone in 23. Woohoo! Thanks. So this is currently behind a flag in 22 and 20, and will probably also get unflagged in similar minor releases in those LTS soon. So this is talk about how we get here. So let's start with a brief history of ESM in Node. ESM in Node had been landed as an experimental feature since sometime around 2017 and went through a long period of collaboration and development, finally unflagged in 2019 and stabilized in 2020. That was about 4 years ago. So when ESM support finally reached stability in Node, it already supported importing CommonJS from ESM. You can import the module.exports object from CommonJS into ESM as the default export. You can import name exports from CommonJS into ESM. Those are detected using static analysis that work with common export patterns, like if in the CommonJS module, you just assign module.exports.log directly. It can be imported by name from ESM. Require is not available in ESM by default, but you can create your own require in the module. When you import in ESM, unlike require, you have to specify the extension. There was also already support for tuple away and dynamic import in ESM by them. There were more specific things about ESM at the point, but for the context of this talk, these are the most important ones. On the other hand, in CommonJS, which was the vast majority of the node code in the ecosystem at that point, there was only very limited support for loading ESM. You could not require a ESM in CommonJS. Dynamic import works, but only in asynchronous paths. And the lack of synchronous require ESM turned out to be the major obstacle in the migration to ESM. That means if a package ships ESM, then it can no longer be used by most CommonJS users. Many users have plans to eventually migrate, but people also have priorities, and they generally prefer to do it at their own pace instead of having it forced upon them. And in the open source world, many maintainers are just too kind to break their CommonJS users, so they continue to ship CommonJS. And this gap was hurting both maintainers and end users. For maintainers, if they ship ESM, CommonJS users get broken. In the case of certain frameworks, if they ship CommonJS, then they can't load user configuration or user exports in ESM. Some try to deal with it by automatically transpiling user ESM, but that just could lead to magical errors when users load some external ESM dependencies that these frameworks don't transpile. Another solution is to ship both, but it's difficult to get right and blow the node modules folder. It also requires build steps to set up, which can be very annoying. For end users, they might be thinking they're actually already using ESM, but writing ESM is not necessarily running ESM due to all the problems. Tools or frameworks they use might be transpiling it into CommonJS magically for compatibility, and then the users will see error require ESM when they try to load external ESM, which can be very confusing because they thought they're already writing ESM. If you search for error require ESM, you can see a lot of people struggling with this on the internet. People who still run CommonJS cannot upgrade dependencies that have gone ESM only, but being forced to refactoring to ESM can disrupt their plans, and some just end up forking or getting stuck with versions that are no longer maintained. This also has a ripple effect. The more dependencies stick to CJS, the CommonJS, more people and sensitive dependencies also stick to CommonJS. And all these actually just demotivate the adoption of ESM. So Titus, I'm not sure if I'm pronouncing correctly, has this nice project that surveys the module types of more than 5,000 high-impact NPM packages periodically. I took the data from there, and as you can see, many package authors chose to ship both CommonJS and ESM to maximize compatibility. That is labeled dual here. Or they chose to ship transpile CommonJS, which are labeled full here. And after 4 years since ESM stabilizing Node.js, only about 20% of the high-impact packages are actually shipping some form of native ESM. And as you can tell, the growth wasn't particularly fast. Many maintainers I've talked to mentioned that the lack of built-in required ESM was the main blocker for them to ship ESM. And maintaining packages is already hard enough. Like, they already should not suffer from reduced reach for trying to adopt the standard, but neither should they suffer from the build steps overhead from trying to be nice and not break CommonJS users. And to fix those problems and make ESM successful requires ESM seems to be a very important missing piece. Outside of Node Core, bundlers have supported require ESM with automatic transpilation. And there are userland required customization packages that does the automatic transpilation, which was actually pretty popular on NPM. But as we've shown with statistics before, these non-built-in solutions were still not enough to truly unblock the ecosystem to migrate. But why wasn't it supported in Node Core? Like, didn't anyone try it? I wasn't involved in the initial ESM development in Node, so I could not only present some GitHub archaeology results and things I learned from those who were involved. So there were some early attempts to support this, even back in 2019, before ESM was stable in Node. There was an attempt that tried to also handle top level away from require, but it was technically unsafe and could lead to crashes. At that point, there were suggestions about not supporting top level away from require, but the discussions got heated and distracted, I guess, and eventually didn't come to fruition. So as far as I could find, there wasn't a clear consensus on yes or no on the general idea. There were only skepticism about the details, and it was just probably just not enough work was done to investigate or disprove them. ESM Node was developed by a very diverse community group. That also means you also get tons of diverse opinions on how every detail should work. And it takes a lot of work to come up with the solution that all parties can be happy with. So there have been users requesting support for required ESM for sure. But in Node, user support only gets you the first 100%. Because Node is a project collectively built by the community. It's not a product provided by a company. So some contributor or multiple of them need to secure the time and energy and expertise and maybe even funding to get it done, or the work just doesn't get done by itself, especially when we're talking about 2020 to 2022. On top of needing more voluntary work than what people had time for, not that many people actually knew that it could be done, that there was this myth of ESM is asynchronous, but require is synchronous, so you cannot make it work. But that was not accurate. ESM is only synchronous. It's only asynchronous if the module or its dependencies contain top-level weight. This is something people who had worked on the implementation or the specification of ESM usually knew, or at least later when I talked to them about it, this seemed to be a common knowledge for those who had the ESM expertise. But most people, including myself before, didn't work on ESM. And since this myth was actually told by the Node documentation, as you can see here, like most people will probably just accept it that it was true. And sometime later, I happened to be reading the ESM implementation in V8 to fix a memory leak. And then I noticed, wait, V8 has separate paths for synchronous and asynchronous module evaluation. And usually for some kind of complex runtime behaviors like this, the JavaScript engines usually just follow what the specification says almost to the letter. So I was wondering, maybe this was what the specification said. Maybe it was the Node documentation that was exaggerating. And that turned out to be true. Here is a look at what the ECMAScript specification says. So these were added in 2019 when the top-level await proposal was settled. When a module is evaluated in the specification, it runs this inner module evaluation method. And if that method doesn't set the async evaluation flag to true, then the module evaluation should just directly resolve the promise to undefined to signal that it's complete. So when does it set the flag to true? Now, if we go deeper and check out that inner module evaluation method, if the module doesn't have any pending asynchronous dependency, nor does it have this has top level away flag, then this flag is set to true, the async evaluation flag. In that case, it would just run this execute module method. When we talk about ESM, we're usually just talking about source text module, which are modules written in JavaScript. So the execute module method of a source text module just runs the code in module. There is nothing asynchronous about it if the module doesn't have top level away. So if we thread them back together, this means if a module and its dependencies are free from top level away, there's nothing that forces it to finish evaluation asynchronously. And therefore, it should resolve a promise to undefined synchronously after evaluation. I'll also confirm this later with people who worked on the specifications, like Laser Dan, who worked on those slides before. And that was actually intentional, and this semantics was also relied on by bundlers. So this means as a host, Node can implement something like this. This is pseudocode. In reality, this needs access to native VA APIs. But the gist of this is to implement require ESM, we can just fetch the module graph and link them synchronously first. That part is up to the host, so we can make it synchronous. Then we can check if it contains top level weight. If it does, we throw, otherwise we evaluate. The specification guarantees that at this point, the evaluation of a synchronous module should finish synchronously, and we can just return namespace with evaluated values to the users. And this is actually not a novel concept. For example, service workers also disallows asynchronous module graphs. The W3C specification also says something like, if the module is async, it should fail. This even saved us from having to add an API to VA to check if the module graph is asynchronous, because it was already added in VA for Chrome to implement this for service workers back in 2020. The specification side also was brought up in the early attempts of require ESM in Node in 2019, but somehow the work didn't happen. So I learned about all this last year, and I discussed with other contributors, mostly Geoffrey, about this. But if we go back to this pseudocode, you can see for this to work, we need a way to fetch the source code and link the static module graph synchronously. But in 2023, the ESM loader in Node was like asynchronous everywhere. And underneath it was like 3,000 lines of JavaScript code that I had barely read before. So I thought, okay, maybe just leave it to other contributors who are more familiar with it to refactor it and carve out a synchronous path. But then earlier this year, I was working on the compile cache. Then I ended up refactoring a smaller part of the ESM loader. And but then I couldn't help but reading a bit more about the whole thing. And then I realized maybe instead of refactoring that 3,000 lines, it would be easier to just write a new synchronous and train down ESM loading path for require. I could already see in my head, and I knew lines added would be easier to backport than lines changed. So that felt pretty promising. So I also asked Bloomberg for support to work on this, and they said yes, thanks. So I started working. It took me one afternoon to dump what I saw in my head into actual code, and this was one of the rare occasions where it actually worked on the first try. It turned out to be even a bit faster than the asynchronous ESM loader because async handling in Node can add a lot of overhead. This is similar to what Isaac talked about yesterday. So I opened the pull request to test the temperature in the room. and other contributors were very positive about this. No one was saying that this should not happen. There were some edges that needed more work, but we agree that those can be follow-ups, and nothing comes out perfect at the first try. Anyway, so we can always iterate while it is behind the flag. So I added more tests, fixed more bugs, got this pull request landed. It was released to 22 and backported to 20 behind the flag. Now, one of the questions we had was whether the lack of support for top-level away would be another problem. Note that we are already only not supporting it in require. Top-level away can still be used in ESM entry points and in modules that are imported. The problem only happens when the module is shared with other people who load away require. But it turns out packages in the ecosystem don't actually use await at the top level that much anyway. We tested on the top 5,000 high-impact packages on NPM. About 1,000 of them are dual or full ESM packages, which already don't use top-level await anyway. About 500 of them are ESM only, and among them, only 6 of them use top-level await. 3 are awaiting on some FS APIs that have synchronous counterparts, and they were using the synchronous counterparts before that got converted to ESM. And 2 are awaiting a dynamic import of some node built-in case they're not running on node. So we added process that get built-in module to fill that gap. The conclusion is that a require that doesn't support top-level await can already work for like more than 99% of the ESM packages out there, and that should be good enough. But landing the first pull request was just the beginning, and that turned out to be the easiest part. In the following month, I got a lot of help from other contributors and package maintainers, people like Jeffrey, Guy Bedford, Nicola from Babel, and Jake from TypeScript, and many more others. We tested out on packages in the ecosystem, fixed bugs on edge cases, and worked out more features to improve module interoperability. Given that there are already userland solutions and workarounds for require ESM, we need to make the built-in version work with those, because if it ends up being server major, it will take a lot longer for package maintainers to rely on it and start migration. But if we can keep it server minor, we can backport this to older LTS, and package maintainers can start migration a lot sooner. In extreme cases, this could be like a 4-year difference in the timeline. We also try to make it work more transparently for code that previously needed bundlers to run, and try to require less modification from users, although it's always a trade-off. So if re-implementing one bundler support would end up breaking more people or be too complex that it will push the timeline even further, we'll take other more viable options. We also try to keep it reasonably performant so that people don't get demotivated to migrate due to ESM just being slower to load than CommonJS. So here is one example of the things that we did to smooth out the transition. A key difference between CommonJS and ESM is how they handle default exports. In CommonJS, the named exports are assigned directly to the module.exports object. In ESM, people tend to use the default export to replace module exports, but that will actually be put on a separate default property of the namespace parallel to the named exports. To handle this difference when transpiling ESM to CommonJS, bundlers and transpilers have already developed a convention. They make the exports object shaped like a ESM namespace, with the default and named exports being separate properties, and a special marker __ES module. And then on the consumer side, if the consuming code is also ESM transpiled into CommonJS, then the transpiled code will contain some adapter to unwrap the default exports in the presence of this marker. Now, suppose a package was previously shipped as transpiled or full ESM, and now it wants to ship itself as native ESM and get rid of the build step, but the consumer code may be maintained by somebody else, and that could still be full ESM. And if we turn the module namespace as is, this would not work together. So the solution is basically follow what bundlers do, add a underscore ES module marker when there are default exports so that the consumer code and the module code can still be migrated independently. The default exports difference can also be a problem for packages that are previously written in CommonJS and now want to migrate to ESM. Previously, this is how you will write the CommonJS module if you want both ESM and CommonJS users get both the default export and named exports separate properly. And as long as you assign to module exports explicitly, the static analysis can detect is for ESM consumers. Now, if you upgrade it to ESM, because ESM doesn't put the name exports on the default export object, you need to assign it yourself for CommonJS to get the name exports. That is not too bad, but the default exports are now different for CommonJS users because it's now placed as a property named default. That means it would be a breaking change for CommonJS users. This is not a problem if the module doesn't have default exports, but when they do, Node needs a hint from package authors to customize what required ESM should return. We cannot just unwrap the default export unconditionally because named exports can get lost. Using the underscore ES module marker as a hint doesn't work either because existing full ESM already expects required to return the transpiled namespace as is. Otherwise, the name exports also get lost. So we had to add another marker, and we chose module.exports as a string because export something as module.exports would be easier to read and remember. So with this addition, a CommonJS package can migrate to ESM while maintaining compatibility to both ESM and CommonJS users, even when it has default exports. Support for required ESM also means that dual packages can migrate to ship ESM only and stop shipping 2 copies. But it takes time for these changes to roll out to active LTS. So there will be a period where some active Node versions have required ESM, while some don't. So here we have a common pattern of dual packages. They may use the Node exports condition in package.json to supply the CommonJS version to both require and import on Node in order to prevent having 2 copies of the same package in the same process, otherwise known as the dual package hazard. In other environments, like when being bundled for the browser, they would use the default export condition to supply the ESM version. But now that they can supply ESM to require on newer versions of Node, how can they pick this up sooner? Actually, bundlers have already a conventional condition named module that can be used to supply ESM on require, which allows them to transpile and produce better code. But we try to pick this up, but unfortunately, existing users of this condition, including some very high-impact packages, are using non-Node resolution rules in their ESM code. So if Node pick this up, it would break these packages. So as much as we wanted to implement the existing condition to save people from more modifications, we ended up with adding a new separate condition instead. This is called module sync. Things require we expect it to be synchronous. With this condition, early adopters can supply ESM to both require and import on newer versions of Node to test things out, and fall back to CommonJS on older versions of Node. The new condition is just a tool for early adopters to ship ESM first during the transition period when some active Node LTS support requires ESM and some don't. The path forward is that when a package no longer supports any old Node versions that don't support require ESM, they can just drop all the special cases and either just use the default export condition or just use the main field to ship only ESM. Now we've talked about packages, but there's also one final hidden dependency in the ecosystem, tools that customize the module loading process, either for mocking or transpiling or instrumentation. Many high-impact tools have been doing this by monkey patching module or require, and this poses an underlying dependency on the CommonJS loader itself. Users can migrate their own code to ESM, but if the tools they rely on is based on patching the CommonJS loader, their workflow will still break. So to help the tools migrate and provide universal support, we need the customization API that is universal and has an execution model close to what they already have. In the case of a require ESM, this is already needed for customizing both the ESM being required and the CommonJS that is calling require. Now, we do already have module register, but they have some limitations that can make it difficult for existing tools built on required customization to migrate. There are 3 aspects of module customization that cannot be satisfied at the same time. For example, before Node 20, module register and the experimental loader flag will run on asynchronously in thread. This means that they will not work on require, which is asynchronous. After 20, they made the breaking change and run off thread so that they can customize require by blocking on the main thread. But being off thread made it harder for customization to mutate exports or pass functions around, which many existing require customizations will need. So to fill this gap, we need a customization API that support running hooks in thread and is effective for require, in addition to being effective for import. That means it can be asynchronous, but out of the 3, that's probably the least required feature for existing tools. And tools today already can and do work around that by spawning their own workers to the async-specific async operations themselves. So the new API, which is now being worked on in a pull request, basically looks like this. It's still similar to module register, but it will just accept functions directly, since existing hooks out there already take user configurations in the form of objects instead of module IDs. Let's say to replace all the fools in the resolve path with var, you can just add a resolve hook and modify the URL resolved by default resolution. Or to pour the example of the pirates package on NPM, you can just implement a load hook to modify the source code. So this API will work for both require and import customizations, which means if ported tools previously based on CommonJS monkey patching can just support ESM by reusing most of the code that they already have. So finally, this is where we are now. Require ESM is currently available by default on 23 as an experimental feature, so it currently emits warning when being invoked for the first time. It's available behind a flag on 22 and 20. We plan to backport the unflagging as similar minor. So we are also aiming to stabilize it by 24 after customization is supported. Then we'll be able to remove the warning on 24 and earlier versions. So thanks for staying with me.
Oh, sorry. Thank you, Joyee. Does anybody have a quick question for Joyee? Oh, we got one over there. Let me go and drop the microphone. Is that okay? Sorry. Oh, sorry.
Does the module sync condition need to be inside Node, or can it be at any point a condition appears?
It can be anywhere, but if people are already using the example was kind of using some kind of existing pattern where people do node module. So in that case, they will probably want to like stack them together with the module so that module is recognized by bundlers and module sync is recognized by node. But like if they don't care about bundlers, they can just like put it somewhere like directly node module sync, directly put it as module sync without using node.
Okay. Well, thank you very much. Can we all give it up for Joyee, please?